Okay, so I'm working away on my Pi 39 radio here, which was made just in a town 5 kilometers from where I am right now, in a town called Ajax, Ontario, right after the Second World War. And let's see, I'm still trying to hunt down what I think is low B+, trying to account for motor boating when the volume control is turned down. It's up full blast right now. So, I've been poking around here a lot. If you've watched the last video, you know that. I think what I'm going to do now is supply a audio signal into, I've done this in the I've supplied an audio signal to the output tube, got good output. So now I'm going to supply an audio signal to the next tube back and see what happens. And I should be able to do that on the grid of this tube. And this guy, V4, is the 6SQ7 that I just put in the radio. So we'll turn to 6SQ7. You know what would be smart for me to do? Either photocopy the pages that relate to the tubes in the radio, or make a little diagram and just draw them out, the 4 or 5 tubes, so I don't have to keep whipping this book open here. 6SQ7. And the grid is pin number 2. So all we got to do is feed an audio signal into grid number 2. So let's do that. I should probably do it through a capacitor. I'll do it through a 0.01. And now, I continue to suffer from a clip lead shortage here. Okay. There we go. So now I'm going to clip the audio signal onto, what was the grid number? I think it was 5, but let's just make sure. 6SQ7. Two. So you see, there you go. Can't trust myself for 10 seconds here. Number 2. Now it's tricky to identify it on this tube because the pin is so hard to see. The key on the shaft of the got too many tools laying around here. Okay, so what we want to do is make sure we know where the shaft is. I'm just moving this wire out of the way here. Careful. Yeah, I think that would be 1. One. That's 1. That's 2. That's 2 right there. And I'm sure if we just touch it, we'll hear a little noise. Let's try it. 2. Yeah. So we hear a little noise in the speaker. I can hear a little noise in the speaker. Oh, just a second. Okay, that was a small distraction related to cat activity, of course. Now, I was about to feed the audio signal into pin number 2 on here, and I'm still trying to convince myself as to which pin is pin number 2. need to identify, since I can't see the pin clearly, and it's either here or there in two possible positions, I just need certainty here. Maybe I can get my, let's try something else here. Where's my little mirror? Well, here's one I don't like to use this one because look, it's all metal. You know, that's not a good thing to be sticking in a radio and holding on to. But I'm gonna just do it very carefully here. And of course, now I'm looking at it, you know, backwards. So what can I figure out from this? It's just, I don't like sticking that in there. I have a nice plastic one, and of course I don't know where it is right at the moment. You know, because I can put this in, I can look at where I'm holding it and be safe. But the moment I look in the mirror, I stop paying attention to where I'm holding it, and the next thing you know, I'm going to short something out. Short myself out. That wouldn't be too good. So I'm chickening out with that one. It's the stupidest thing, isn't it? It's just right in a spot where I cannot see it, for crying out loud. This requires a strong action. I mean, I can eliminate all these other positions. So that, well, it has to be there. Pin number 1 is connected to pin number 8, shorted over to pin number 8. Pin number 1 is also grounded. Pin number 8, this might make sense. Okay, this might prove it to me. Pin number 8 is probably the cathode. 6SN, no, 6SQ. 6SQ7. Pin number 8, pin number 8's a heater. Cathode is pin number 3. So, pin number 8. Pin number 7 and 8 are heaters. Huh. Well, I see what looks like a heater line on what would be pin number 7. That would make that pin number 8, and that would make 8 shorted to 1 and grounded. And pin number 1 is nothing. So maybe that's what's going on there. That's the last heater in the row, so to speak, or no, these aren't in series either. They're in parallel. So maybe that's the case with each tube. You have a heater line coming to it, and then the other side of the heater is just grounded to the chassis. It might even show on the schematic that way. Yeah, that's exactly what it shows. One side connected to the heater line, and the other side to ground. This is crazy. I'm just trying to convince myself I'm looking at the right pin on this tube. So now I know which one's pin 2. So now I know where to connect my signal generator. Wow, this is just crazy stuff. Pin number 2 would be that one. Very interesting. So I get onto it right there. Look at that. Hey, and the volume control works properly now. Where's the motor boating? I mean, I can't turn it down because I'm not feeding the signal into the volume control. We'll do that next. It's not terribly loud, but then I'm not feeding much signal. Let me turn up the signal level going in. Well, I'd suggest that last tube is working, even with the B plus it's got. The apparently low B plus. And I have that capacitor connected in. Better keep my eyes on that. It's sitting on my bench here with clip leads. I don't want to stick my fingers on it. Well, let's move further up into the radio. We'll leave the input signal the same level. And we'll go from the grid. We'll go from the grid to the slider on the volume control. That makes perfect sense because that's where the signal is picked off to go. Okay, slider on the volume control. It's the other side of this capacitor. Hey. No signal. It's one of these molded capacitors here. Hey. That's barely soldered. So, how much you want to bet? That capacitor's a dud in there. Let's bridge it with a good one. It's a 0.1. I should just stop and replace all three of those molded capacitors right now. That's really what I should be doing. Okay, so how can we bridge that? Can't use that clip lead. Can't use that one. I'm really suffering from clip lead shortage here. One clip lead. Give me one clip lead. Give me a clip lead that's just one clip. That's even enough. No. Ah. I hate being slowed down by stuff like this. Sure happens too much. Okay, so how else can we bridge that thing? Okay, so we can bridge it this way. This is kind of a dumb thing. Because I have the capacitor right here. So yeah, but what I want to try to do is feed the signal in here, where it's being fed in, where it was being fed in. Oh, hey, here's a clip lead. I got a clip lead. Okay, so the signal's being sped in through this supposedly bad capacitor. Let's crank it up a bit. You know, it's making it in there. But you can see how much signal is being lost because when I connect straight to the other side, we hear it. On this side, don't hear much of anything. So, you know, it says 0.01 microfarads. Maybe it's actually 0.00000. It has no capacitance anymore. So now I can clip across it. So we'll clip this guy here. Clip that guy there. Now this is a 0.1, so this is pretty big in comparison. Nothing. Ah, wait a minute. How can that be? Well, why would connecting my signal generator signal to the point where the audio comes into the audio amp? Well, that says something bad back here. And guess what? There's more of those crummy capacitors. I'm going to change those out. I think I should just do that. So we'll kill off our radio here. So So I'll change 1, 2, 3 capacitors. I should verify the size, just in case when I did this I was using scrappy capacitors because I didn't have the right size. So the challenge here, let's see, that's pin number 2. Pin number 2 on that's the grid. Essentially that's the capacitor. It's C, oh, for crying out loud, C53? Would that be right? No, they don't go that high. This has got to be C. I lost track of where I was. Oh yeah, off here, right we are. C right here. C, it looks like 33. I think that's 33. 33. Okay, so C33 is supposed to be a 0.05. They got a 0.01 in there. Yeah, so I'm gonna have to replace these guys. We can start right with that one. 105. 0.05 right now. .05. That guy right there. You know, it's so poorly soldered in there, man. This is bad work by me. I think I must have done this like 15 years ago or something. I could have done this much longer ago, yeah. Come on out of there. There's nothing holding you together anymore. Just stubbornness. There we go. Now, I got a bunch of capacitors laying around here. Which one is it? It's not that one. It's this one. Just passed the soldering iron from one hand to the other. I almost grabbed the hot end of it. Boy, that would have been a disaster. Can't say I've ever done that before. But I have certainly learned to not hold the soldering iron in your hand while you do other things. That's really not a smart move at all. So you often hear me returning it to its holder to get it out of my hand, literally. Well, those aren't going to reach. So I need a little piece of wire here to extend that. And where would a nice piece of wire be? It'd be over here. I like to use a single strand wire for this kind of thing, because the multi-stranded wire, you end up with a mess trying to wrap it around. I'm sure everybody is well aware of what happens if you try to use stranded wire to hook things up. And the idea of stranded wire, anyway, is there's a number of ideas, but the main one is flexibility. You strand up the conductor to get flexibility. Because a solid wire is not very flexible. You can imagine if this was on the end of your vacuum cleaner, you know, a suitably sized wire on your vacuum cleaner, you wouldn't be coiling it up. So we'll put the extension on here. If I move it up close to the capacitor body, then there won't be much exposed wire here too, which is probably a good idea. I'll just cut away the excess wire. Yesterday I was working on a modern 100-watt receiver, a real nice one, probably from around 1980 or so. No output on one channel. Traced it to the driver transistor for the output transistor. Seemed to test okay in the circuit, so I took it out. I tested it out of the circuit. The driver transistor tested fine. Okay. I put it back in, and guess what? Everything was working. There's another story of how this work goes. So it was probably a cold solder joint on the transistor I removed, and when I put it back in, I solved it. But couldn't figure that out ahead of time. Trouble seeing what I'm doing here. Another thing you don't want to hear your surgeon say when he's working on you. Take it all. Sorry about my arm, but sometimes the work has to take precedence. Oh, come on. This is terrible. Okay, let's see if we can mechanically get that wire to grip onto there. cheated myself by not stripping enough wire, enough insulation there. Sometimes you have to have a little bit of solder on the end of your soldering iron, just so the soldering iron will conduct heat fast enough into the part you're trying to... Oh, for crying out, I knocked the wire right off. So I'm soldering nothing here. It's on there. Gee, I wonder if we should test these one at a time each time we do one. Yeah, why don't we do that? No harm turning the radio on. Safety check. The speakers are still connected. No input signal anymore. We're good. We're good to go. Good to go. So we're going. Volume is down, because this is actually the signal coming out of the radio part, traveling on this wire, and from here it's going into the I think that's the detector first audio amp, and I think it generates the AVC voltage too, so that's a busy tube there. Okay, let's turn it up. Well, I think that tells the story. We haven't made much difference yet. So now we'll go after this one. This guy is probably a .01 also. I'll bet you I got desperate back then. Didn't really have the capacitors I needed, which happens from time to time to everybody. And I went and made this disastrous situation occur. So this is at the end of this 20, looks like a 220K resistor coming off the volume control. Is it coming off the slider? No, it's coming off one end of it. One end of it. Ooh, R10, yeah, R10, I've already written it in there. R10, 220K, so now R10 then connects to a capacitor called C31. So now we'll read how much. What's C31? C31 .02. Yeah, C31 .0. It's either 02 or 05. I'm gonna look with my magnifying glass. .02. Okay, so 0.02 and I got 0.01 in there. Well, that's not much different, is it? 100% different. 0.02. 0.02. Make sure I really know where this is coming from, because too easy for me to forget. .01. I'll put the .02 in. Yeah, that's enough. That you know, that's double the capacitance. Now my guess is that, yeah, you know what? This .01 is probably weak. It's less than .01, I bet. And so maybe it's quite a ways from being a .02. You know, I can do a better job there. Sometimes I'm making some rather strange hand, I want to say movements, hand positionings, and the reason is the camera is right here in my workspace. And as much as I'm trying not to block it, at times it's just simply in the way of where I want to put my hand or something, so I have to come up with some kind of alternative way. These capacitors I'm using are all 600 volt capacitors. I don't think there's many radios that go beyond, really much beyond 300 volts. I don't know what tubes would require much higher, or any higher voltage really. There's a loose piece of wire there. Whoop, got it on the end of my soldering iron. Okay. Looks good. Let's try the radio now. See if that was the bad guy. Safe to go. On she comes. Volume is down. Another reasonable possibility here is that I put a capacitor in the wrong place when I did this before, so that's why I'm verifying which capacitor it is and what its location is. And let's turn it up. My radio is literally croaking in front of you here. So, okay. That didn't help much. One more to go. One more to go. Now this one is at the far end of the volume control. That's this one over here. A little hard to see back in here. And this capacitor I'm a little suspicious of too, because I'm the guy who put it in. Did I do the right thing? Okay, so this is the other end of the volume control from the end that we just did a capacitor on. The other end is here, coming along here, coming down here, coming in there. Oh my gosh, would that be it? C41? It's kind of right on the switch. No, we're on the volume control here. Go back. It's coming right off the other end of the volume control. Directly connected. Well, there's one. That's not really directly connected. Go up here. Oh man. I don't see any capacitor. Where's that capacitor connected to? It would be wonderful to find out it's just wrong. So it definitely comes off. Comes off the back here. It's connected to this 22K resistor. Let's see how that works out. 22K resistor. I don't see any 22K resistors involved here. That looks like an original resistor. It's coming off the non-slider. There it is right there. It would look like R9 to me. R9 is 22K. Yeah, that makes sense, right? Because it's red. So there we are, 22K. And that's R9. R9, where'd you go? R9. I've lost track. There's R9. Coming off the back I don't know what to call it. I call it the fixed slider. That's the tap. Let's call it the tap. This is the tap. So R9 just goes to ground. Yes, it does. Oh, that capacitor is going to ground. That's just a ground point. Okay, so maybe that capacitor has nothing whatsoever to do with the volume control. It's just using its ground spot there. So let's look at the other wire. The other wire is a white one that goes down. Oh, it goes into the switch. Yeah. Save me from these switches, please. Okay, so that's what it does though. It goes in the switch. Would appear to come right back out of the switch. Looks like the switch is just switching here to here. That being the case, then, well, let's be absolutely sure of this. It's probably not what's going on at all. Don't make that assumption, Jim. That's a stupid assumption. So we have it going to the switch. Yikes. Here's the switch parts down here. So in other words, this is a wire. Oh man, which wafer is it here? It's showing 4 different switch elements. 2 wafers. So it's a front back to get 4. Doesn't seem to be hinting which one's which at all. I hate these switches. They blow my mind is what happens. Powie. Yeah. I apologize again for not having the best camera shot here. So here's the switch I'm talking about. Band switch. What should we do here? That wire, the white wire to which this capacitor is connected, goes nowhere else but to this capacitor, and the capacitor goes nowhere but to ground. So can we see that on here? Can we see somewhere where there's a capacitor, like right here, right there, right to ground? So there's one that does it. C20 what? I'd say C28. So we go to C28. C28, 0.1 microfarad. 0.1 microfarad. And what about, I bet you I got a 0.01 in there. That's way off. Is that really that capacitor? I don't know. There's some other capacitors that come off that switch and go straight to ground. Hey, here's a capacitor here that's connected to a wire that goes all the way up to the back slider. That's this red wire. No, that's this red wire. Everything off? Yep. Red wire goes down there. Uh-oh. I think there's a capacitor hidden back there. Right in the center of the screen, I believe that's the end, that orangey thing is the end of an old capacitor. Get another look at it this way. just to the left of the resistor. And on the other side of the switch. Look at, what is that? That looks like a wire, doesn't it? What is that? On the far side of the switch. Center of the screen. Doesn't that look like a wax capacitor? It sure do. Wow. Yow. This one I never changed. Well, problems are mounting here. Problems are mounting. See by my watch it's just about lunchtime, so I think I'm going to stop at this point. Carry on with the proving when I come back. Carry on with the proving of what this capacitor is, replacing it, verifying this capacitor here. And the reason for that is I may have made mistakes in this area. We're getting motor boating. The motor boating is related to the position of the volume control. Just some light logic suggests the problems are around the volume control. Some heavy logic is, no, you're completely wrong. You should just go eat lunch at this point. Go away and think about it. So anyway, interesting times with this radio, but you know what? We're going to get this thing working. And I love this radio. I used it a lot. Apparently I used it a lot until I stuck the wrong tube in it. Then I set it aside. So, anyway, thanks again for watching. I hope you're enjoying this. I know it's a bit of a, fishing around in the radio, and I certainly spend a lot of time doing that. But I think we will nail this down and get this guy working. So, see you on the next video.